Alright guys, this is section 4.2 homework, and we're going to be doing the evens on practice B. Alright, so number 2 says 2 square root of negative 40, and we're asked to find the square root of the number. So here what we're doing is reducing the radical using those properties that we learned earlier for that lesson. So here, 40, the largest square root that goes into it is 4. Yeah, 4. So I can split this into 2 times the square root of 4 times 10 times negative 1. Right. The square root of 4 is 2, so I can pull out a 2. The square root of negative 1 is I, as we learned earlier too. And what's left inside is the square root of 10. So all I have to do just here is multiply my real numbers here. So I'm left with I square root of 10. Final answer. Alright, number 4. On number 4, I'm asked to find the values of x and y that satisfy the equation. Here I have 2x minus 3yi is equal to 14 plus 12i. So here, if these two things are to be equivalent, that means that their real part has to be equal. So I'm going to set that equal to each other. 2x is equal to 14, and the imaginary part has to be equal. So negative 3y is equal to 12y. Negative 3y is equal to 12. Right, so here all I have to do is just solve for x, and then the same thing here, solve for y. So in my x equation, all I have to do is divide by 2, and I'm left with x is equal to 7. And on the y, it's just divide by 3, negative 3 on both sides. And I get y is equal to negative 4. Alright, number 6, same thing. Number 6, I have 22 plus 1 over 5 yi is equal to 2x minus 2. So again, all we're doing is just setting the real part equal to the real part and the imaginary part equal to the imaginary part. So here I have 22 is equal to 2x. 22 is equal to 2x for the real part, and the imaginary part I have 1/5 y is equal to, oh, is that 2i? Oh, that's 2. I think that's a typo. That should be 2i. To 2, so 2i. Oh no, it's not a typo. No typo. Here's the whole side of my equal sign over here. 2x minus 2 is the real part, so that entire thing is equal to 22. So on this part, add the minus 2, and then on the right side of my equal sign, I have no imaginary part. So my equation here for the imaginary part should read 1/5 y is equal to 0, since I have no imaginary part. Alright, so this part's easy. All I have to do is just multiply by 5 on both sides. 5 over 1, 5 over 1. So my fractions cancel, and I'm left with y is equal to 0 times 5 is 0. So y is equal to 0, and then here, add 2 to both sides, I get 24 is equal to 2x, and then divide by 2. 24 over 2 is 12, is equal to x. Alright, number 8. Number 8 reads, alright, now here we're adding or subtracting, and the imaginary number that we're subtracting is that one right there. So that's 9 plus 6i minus 15 minus 7i. Right, so when we're subtracting complex numbers, we add the real parts or subtract the real parts, and the imaginary parts we add or subtract them, whatever it may be. So 9 minus 15 is negative 7, negative 6. And positive 6i minus negative 7i is the same thing as 6i plus 7i, which is positive 13i. And we're done with that. Alright, number 10. I'll do it right here. Number 10, same thing, we're adding or subtracting complex numbers. So number 10 reads 14 minus quantity 17 minus 7i plus 8i. So here we're doing the same thing, we just combine the imaginary numbers and the real parts. So the first thing I have to do here is distribute this negative, don't forget about that. So distribute this negative, and I get 14 minus 17 plus 7i plus 8i. Once you distribute your negative, all you have to do here is just combine your real parts. So 14 minus 17 is negative 3, and 7i plus 8i is positive 15i. And we're done. Number 12. Number 12 reads, the additive inverse of a complex number is z. So additive inverse of a number is z is a complex number za such that z plus za is equal to 0. Find the additive inverse of each complex number. Alright, so here what they're telling us to do is to find some sort of complex number that when we add it to this other complex number, we get 0. So in order for that to happen, we need to add the negative of this number, of the real part, and the negative of 3i as well. So everything just changes signs, and then that's what we're adding. So what that looks like algebraically, so if I'm looking at 12a here, 12a reads z is equal to 2 plus 3i. And if I want z plus some za is equal to 0, well, I need some real part that I added to 2 such that it gives me 0. So what that looks like is 2 plus some a is equal to 0. And then I need an imaginary part that I added to 3i that I get 0. So that looks like 3i, or rather 3 plus b is equal to 0. So my goal is to find some number a plus bi is equal to za. So here all I'm doing is just solving for a, and then here is just the same thing, solving for b. So I'm going to subtract 2 from both sides, and I get a is equal to negative 2. And then here the same thing, subtract 3 on both sides, and I get b is equal to negative 3. So my complex number is going to look like this, which is standard form. All I have to do now is just fill in my a and my b. So my answer is negative 2 minus 3i. That is my complex number. My additive inverse, rather. Alright, number 14. Oh, I still have other parts. Number b. So here if we notice the pattern is just the inverse, or rather the opposite of whatever complex sign is in front of it. So if this is a positive 4, my complex number should be negative 4, and then if this is a negative 4i, my additive inverse complex number should be positive. So for part B, my answer should be negative 4 plus 4i. All I did there was just change the signs of these two. And then for C, my complex number is negative 5 plus 2i. So here my additive inverse would be positive 5 minus 2i. 5 minus 2i. Minus 2i. Alright. Now we're done. Number 14. 14 reads, multiply and then write your answer in standard form. So here my problem is 5 minus 3i times 5 plus 3i. So here we're using the FOIL method since it's a binomial of complex numbers. So FOIL, 5 times 5 is 25. 5 times 3i is positive 15i. Negative 3i times 5i is negative 15i. And negative 3i times 3i is negative 9i squared. So here we have to remember that the square root of negative 1 is equal to I. So if we square I, then we square the square root of negative 1, which is equal to negative 1. The square and the square root just cancel. And that's what happens here. So if we combine like terms, I have 25. 15i minus 15i is 0, so those two go away. And I'm left with negative 9 times negative 1, since I squared is equal to negative 1. So here I get 25 plus 9, which is 34. Right, number 16. 16 I have 6 minus 4i squared. So here, don't make the common mistake that most algebra students make, even college students as well. Do 6 minus 4i, and since we're squaring it, we're multiplying by the same thing. 6 minus 4i. And again, FOIL method. 6 times 6 is 36. 6 times negative 4 is negative 24i. Negative 4i times 6 is negative 24i. And negative 4i times negative 4i is positive 16i squared. Combine your like terms, and then use the definition of I and change that to a negative 1. So that's 36 minus 48i. I squared is negative 1, so 16 times negative 1 is negative 16. So here we get 36 minus 16, which is 20, minus 48i. Final answer. Alright, almost done, guys. Number 18. We have in exercises 18 and 19, solve the equation and then check your solution. So here our problem reads 18 squared plus 16 is equal to negative 28. So we subtract 16 from both sides, and I get x squared is equal to negative 28 minus 16 is 14, 3, 44. Negative. So if we take the square root of both sides, the largest square, perfect square that goes into it is 4. So I can split this into x is equal to plus or minus the square root of 4 times 11 times negative 1. Square root of 4 is 2, so I can pull that out. So I get x is equal to plus or minus 2. The square root of negative 1 is I. And then what's left inside is the square root of 11. So here I have two answers. Every time you take the square root, remember you have to take the positive and the negative as well. Alright, last problem here, guys. Number 20. Number 20 says, find the zeros of the function. So what that means is that we're solving negative x squared minus 4/8 is equal to 0. Since we're finding our zeros, we set it equal to 0, and then solve any method that we can. So here I'm going to add x squared to both sides, so I can get rid of that negative x squared. And I'm left with negative 48 is equal to x squared. And then the same thing here. Take the square root of both sides, square root of both sides. My square and my square root cancel, so I'm left with x is equal to, since I'm taking the square root, I have to take both the positive and the negative, square root of negative 48. And now here we have to reduce it. 48, let's see, I can do 48 divided by 4 maybe. That's 1, and then 2, and then 4 goes into that as well. So 16, does 16 go into 48? Divided by 16, and that's 3 maybe? Yeah, 3. So 16 is the largest perfect square that goes into it. So 48, I'm going to split up into 16 times 3 times negative 1, plus and minus. Square root of 16 is 4, so that's plus and minus 4. The square root of negative 1 is I, times the square root of 3. Alright, that's it, guys. If you have any questions, go ahead and leave them in the comments, and I'll get to them as quickly as I can.